In this video, we'll discuss about palindrome number. So the question is saying that given an integer x, return true if x is a palindrome and false otherwise. So we are given integers as an input and we need to check whether it is a palindrome or not. Now what is a palindrome? If you reverse this number, then whatever number you get, if it is same as the original number, then it is a palindrome, otherwise it is not. So for example, in this case, if I will reverse it, then this 1 will become the first digit, this 2 will become the second digit and so on. So this will be 1, 2, 3, 3, 2, 1. Now these are same, so this is a palindrome. In this case, what will be its reversed? 2, 5, 3, 2. Now these are not equal to. So this is not a palindrome number. In this case, it will be 2, 3, 2. So these are same. So it is a palindrome number, right? So what we need to do is we need to reverse this number. And if we are able to reverse this number, then we can compare this and its reversed form. And if they are same, we'll return true. Otherwise, we will return false, right? So how are we going to find the reverse of this number? So what we'll do is we'll take one digit from the end of our number and we'll keep on adding it to our reverse number and we'll remove this last digit from here, right? So if let's suppose my x is 1, 2, 3, 3, 2, 1. So initially my reverse will be 0. I'll take the last digit from x and I'll add it in r, right? So this will be removed from here and now r will become 1. Then I will take the next digit from here and I'll add it in r. So now it will become 12 and this will be removed. And then I'll do for 3. So it will be removed from here and added here. Then for this, then for this, and then for this, right? So your initial number was this and now your reversed is this. You can compare these two, right? So now how are you going to reverse it? So let's suppose this number was n. Okay, so first you will create a copy of your n. So int x equals to n. And you will create another variable reversed, which will be initially 0. Now you need to get all the digits of this number, right? Now initially you don't know how many digits are present in your number. So you don't know how many times you are going to loop. But if you closely look here, we were taking one digit from x and we were adding in reverse. So when all the digits from x will be added in the reverse, our x will become 0, right? So we can put a condition of that while our x is not equals to 0. Till then you perform this operation of taking the last digit from x and adding it in reverse. Now how do we get the last digit from a number? If we do its modulus with 10, right? So we get the last digit. So we get the digit equals to x modulo 10. So this will give you the last digit. Now this digit has to be added in r, right? Initially your r is 0. So now we cannot simply add that digit in r. Why? Because let's suppose when I had taken this last digit, my r became 1. Now when I'm taking the next digit, which is 2, if I will do r equals to r plus digit, then what will happen? 1 plus 2 will become 3. But I want it to become 12, right? So to handle this, what we'll do? We'll do r into 10 plus digit. So this will keep the digit at the next decimal place, right? So we'll do r equals to r into 10 plus d, right? And we'll remove this digit from x. So we'll do x equals to x divided by 10. When we'll do this, only this much part will be left. So this will keep on performing while our x is not equals to 0. And at the end, we will check that if r is equals to n, then our answer is true. Otherwise, it is false, right? And in the question, it is given to us that the number can also be negative, right? So a negative number can never be a palindrome. Why? Because if I have written minus 121, then its reverse will be 121 minus. Now, this is nothing, right? So for negative numbers, the answer will always be 0. So in the starting itself, you can keep a condition that if your n is less than 0, your answer will simply be false. Now, if you closely look here, that for finding out the reverse, we are tracking all the digits of x, right? We are taking one digit and adding r. So this loop will run how many times? Whatever are the number of digits in your x. Now, can we reduce our number of iterations? Let's see that. So if this is a number, what do? We compare the first digit with the last digit. Then we compare the second digit with the second last digit. And then we compare the third digit with the third last digit and so on, right? So if I say that in one variable, I have this half number and in another variable, I have the other half number in reversed order, right? So this is the first half and this is the second half. So I'm saying, let's suppose in x, I get the first half and in another variable r, I get the second half in reversed order. Reversed order of 3 to 1 will be 1, 2, 3. Then I can compare these two, right? And if they are same, then that means it is a palindrome. Otherwise, it is not, right? So in this case, you would only be taking these many digits, like half of the digits, and you will be reversing them and storing them in some variable. So your number of iterations will be reduced by half, right? In this similar case, if we keep comparing, so we'll compare this 2 with this 2, and then we'll compare this 3 with this 5, right? So this is half of the number and this is half of the number. So x will contain 23 and r will contain 52. Now in this case, these are not the same, right? Then if you see here for 232, now here, see, in these two cases, are the number of digits were even. So that's why you were able to split. But in this case, if you see, we compare 2 with 2, but this 3 is alone. We do not have any other digit to compare 3 with, right? And if we reverse it, then 3 will be intact at its place. It will never distort the condition of being palindrome. So we don't need to compare this 3 with any other digit, right? So now what we'll do is we'll reverse half of our number from the end. So initially what we were doing, we were taking last digit and then we were removing it from this number and we were adding it in our reverse, right? We'll do the similar process, but we'll do it only for the half digits. That means we will change our while condition somehow. So that we'll see what all changes will occur. So first of all, we'll check that if our n is less than 0, means our number is negative. Or now there will be one more condition. Let's suppose the number is 100, right? What will be its reverse? 0, 0, 1. But 0 never appears in the starting, right? In the numbers, we never have leading zeros, right? So if your number is having the last digit as 0, then it can never be a palindrome. But if your number itself is 0, then its reverse will also be 0. This is a palindrome, right? So if your number is not 0, and your number's last digit is 0, right? Then in that case, your answer will always be false, right? Then we'll move forward. Now we will iterate, right? Before iterating, we'll create a variable. So in text, we can copy n here and we'll create a variable r whose initial value will be 0. So now we will loop. So now what will be the condition of our loop? So if you will see here that when I have this number, let's suppose it is stored in x, 1, 2, 3, 3, 2, 1, and I have a reversed variable whose initial value is 0, right? I will keep on taking one digit from here and I'll keep on adding in the reverse. Now, initially this x is greater than r, but there will be some point when this x will either become equal to r or it will become less than r. And that point will occur when you have taken half of the digits from here to here, right? So our while loop condition will be that while our x is greater than r, then you keep on taking digit from x and add it in the reverse, right? So we'll do r equals to r into 10 plus your last digit, x modulo 10. And then you will remove that digit from x, right? And then at the end, what you will check that if your x is equals to r, then return true, else return false, right? So now if you see here, if we check for this, so initially our n is not less than 0, right? And our n is not equals to 0. And n modulo 10 is also not equals to 0. So this condition will be false. So it will come here. So now x will contain this number, r will be equals to 0, right? So I'll write it here. X equals to 1, 2, 3, 3, 2, 1 and r is 0. Now is x greater than r? Yes, it is. So now it will do this. So r into 10, 0 into 10 plus x modulo 10 will give me 1. So this will be 0 plus 1 equals to 1. So r will become 1. And then we'll remove the last digit from x. So it will become this now, right? Now we'll go to another iteration. Again, x is greater than r. Yes. Then we'll do this. So it will be 1 into 10 plus the last digit, which is 2. So 10 plus 2. So this is 12. So this will become 12 now. And we'll remove the last digit from x. Then again, is x greater than r? Yes, it is. So we'll do 12 into 10 plus what is the last digit? 3. So 120 plus 3, which is 123. So this will become 123 now. And this last 3 digit will be removed. Then we'll check, is x greater than r? Now at this point, our x is not greater than r because they are equal now. So this will stop. Now we are checking, is x equals to r? Yes, it is 123, 123. So we'll return true, right? But now if you consider this case, 232. Now in this case, what will happen? Your x is 232 and your r is 0, right? So we'll come inside this, x is greater than r. Now here what will happen? 0 into 10 plus 2. So it will be 0 plus 2, that is 2, right? So r will become 2 and the last digit will be removed from here. Then is x greater than r? Yes, it is. So now it will do 2 into 10 plus the last digit, which is 3, 20 plus 3. So it will be 23 now. and this 3 will be removed from here. Now, is x greater than r? No, it is not. But now when you will come here, your x is not equals to r because x is 2 and r is 23. So in that case, it will return false. Now this is wrong because 232 was a palindrome number, right? So what we'll do is, as I said you, that in this case, we were comparing this 2 with this 2. If there were a number here, then we would have compared these two. But for this 3, we do not have any other number to compare with. And this will never distort the condition of palindrome. So we can simply ignore it. So what you can do is, you can remove this last digit from R, and whatever is the remaining number, that you can compare it with X. If this remaining number and X are same, then it is a palindrome, otherwise it is not. So here, we'll add another condition that if X is equals to R by 10. R by 10 will give you what? 23 divided by 10 will give you 2. So now X is equals to R, so it will return true. So I hope you got it. So now let's code this. So first of all, we'll check that if X is less than 0 or X is not equals to 0 and the last digit of X is equals to 0, right? Then we'll return false. Then we'll create a reverse variable 0. Then we'll iterate while X is greater than R, right? And we'll do R equals to R into 10 plus the last digit of X, right? This X was given to us in the input. And then we'll remove this last digit from X. So X equals to X divided by 10. And at the end, we'll check that if X is equals to R or X is equals to R divided by 10, right? So now we'll run. So you saw, right? We only reversed half of the digits from the end. So we reduced our number of iterations to half. So now let's submit this. So it got accepted. Thank you so much for watching.